Recording?
I started.
Okay.
Yeah, start.
Good evening, one and all present here. I, Rohini Khalkar, welcome you all on behalf of Department of Computer Engineering, Bharati Vidyapeeth deemed to be University College of Engineering, Pune, for 2 weeks hybrid mode Atal FDP on emerging trends in data science and analytics from 31st October to 11 November 2022, sponsored by AICTE's Training and Learning Academy. Now I welcome today's speaker, Dr. M. Venkatesaran, Head of the Department of Computer Science and Engineering, National Institute of Technology, Puducherry. He has his specialization in spatial data mining. He has more than 20 years of teaching experience, and he's working in the areas of database, data mining, data science, big data, geospatial data science, machine learning, and data analytics. He has completed ISRO funded project titled GIS based early warning landslide susceptibility model using data mining classification approach, fund of rupees 10.95 lakhs. He has also completed DST funded 10 days training program on big data analytics. He is also guest editor for special issue on advances in web search and analytic approaches for big data, International Journal of Web-based Communities, Indus Science publisher. And he is also author for edited book titled on cognitive data science methods and models over Internet of Things, Springer series on lecture notes in data engineering and communication systems in 2016, and he has published more than 35 papers in peer-reviewed journals as well as 20 papers in reputed international conferences. So we had previous session on classification and clustering by Dr. M. Venkatesaran, and it was very interactive and knowledgeable session. So I request you, sir, to start with today's session on predictive modeling. Thank you, sir.
Yes, thank you, madam. Already you had an introduction once again. Yeah.
Yeah.
Thank you. Thank you. Yeah. So adding to this, yeah, you are also doing currently another project funded by DST,
Oh,
uh, which is on like no analyzing this. You know that today the problem is fake news.
fake
So
news. Yeah.
so the idea is to find the anomaly detection in social networks using
Multi-graph
machine.
detection model for social network analysis using machine learning.
Yes, yes. Project which is ongoing. And yeah, and recently we also conducted this high-end workshop sponsored by DSP said. Is all we are doing. Okay, thank you. So thanks for the introduction. So as I discussed, yeah, my title for one day is classification and clustering, and another day is predictive modeling. But even though we have already discussed about the classification, so you know that in machine, in supervised, you can call it as predictive analytics, or in supervised machine learning, there are two categories. So classification, you already discussed. I have given one Bayesian algorithm, and I have shown you in tool how to build a predictive modeling already. Okay, and today we will focus on other one prediction. So first we will focus on the prediction, then you will go for the. I think whether I covered classifier accuracy, measures for classifier
No,
accuracy.
no, no, sir. Accuracy or not.
Okay. So we will discuss about the prediction models, and then
Yeah.
we will do the how to evaluate the performance of the classifier, as well as how to evaluate the performance. What are the metrics which are there for to evaluate the performance of the prediction models? Then we will move to the clustering. That is the idea today. Okay.
Yeah.
Right.
Yes.
I hope my slide is visible to you. Madam, my slide is visible.
Yes. Yes, it is visible.
Yes.
Yeah. Oh. So predictive modeling. So you can call it as predictive modeling or predictive data analytics or supervised machine learning. So there are two. One is first you discuss classification, and second one is the prediction. So here, what is the difference between classification and prediction? I hope you remember I have shown you the COVID-19 data set where you had a class label. Okay, so that class label is a COVID-19. The values are, if it is yes or no, then it is a categorical data. Basically, when you look, the data are classified into categorical data and then continuous data. So if the data, the class label has categorical data values, then we will go for classification. If that class label value has numerical data, then we will go for prediction. So you can say a prediction is similar to classification. Like no, you have two steps. One is constructing model. Once the model is constructed, you will be using the model to predict a continuous, or you can call it as ordered value for a given input. Okay. So what you are trying to do in the prediction, you are trying to predict the missing numerical value. In one line, I can say like that. Okay. Prediction is a process which is used to predict a missing numerical value. For that, you are using prediction. Right. So when you look the major method for prediction, regression comes under this. Okay, regression is one of the good example or algorithm for the prediction. What it does, the regression model, the relationship between one or more independent or predicted variable and a dependent or response variable. Okay, that I will explain you. So actually, the regression gives the equation. The equation is y is equal to w0 plus w1 x, and there are two variables. Y is one variable, x is another variable. Okay, and this y is called as dependent variable because it's depending on x. Okay, always y will be predicted based on x, and the x is called as independent variable, or you can call it as a predicted variable. Okay, and this y is called as a dependent or response variable. So there are different type of regression analysis we have. We have linear and multiple regression and non-linear regressions. And apart from that, there are other regression models we have, like Poisson regression, log linear models, regression tree, lasso regression. There are many, right? But our focus is to understand what is linear regression. So if you look the linear regression, as I said, this is the equation y is equal to w0 w1 x. So this is the equation, very important equation. So what it does, it models the two continuous values. Y is the one continuous value and x is another continuous value. By using regression, you can model these two values, which right, you can model the two values that will be like this. So that will be x and that will be y. So this is a line which is formed by this equation. This, okay, it should be straight, right? So this is the linear regression. So as I said, there are two variables involved, y and x, and y is called as dependent variable because it depends on x, and as well as it is called as a response variable. So you can call it as a dependent variable or response variable, and x is called as independent variable because it's not depending on y. Okay, it is independent, and which is also called as predictive variable because by using the value of x, then only we will try to predict what is y, right? So y is equal to w0 plus w1. Got it, right? And what about this w0, w1? And w0, w1 are nothing but the regression coefficients. So the w0 is nothing but y-intercept, and w1 is called as a slope. Okay, these two are called as regression coefficients. Okay, and how to compute this w0, w1? There is a method called least square method. By using least square method, you can try to compute this w0, w1. So you must know this equation and you must know this formula. If you want to compute w1, it's nothing but summation of I is equal to 1 modulus of d xi minus x bar yi minus y bar divided by a summation of I is equal to 1 to d xi minus x bar square. Okay, So if you have this, then we can compute W1. Once W1 is computed, then you can try to compute W0. W0 is nothing but Y bar. Y bar is nothing but the mean of Y, and X bar is the mean of X. Okay, we have already computed W1 by using this formula. So if you substitute it, W0 is nothing but Y bar minus W1 multiplied with X bar. We'll get W0. So once if you have W0, W1, and substitute in this equation, and you will be getting some X value that also you have to substitute so that we can put it to Y. Okay. This is called as a linear regression. But what happens, for example, I can give you example. I want to predict what is the price of the land if the square feet is per square feet, the price of the land per square feet is 1,000. Okay, right? So I want to predict if that land square feet is 2,000 square feet, then what will be the price? So I have already some data, right? The square feet, okay, and then the prices, right? So I want to predict this. If I want to buy a land with the size of 2,000 square feet, what will be the price, right? So here the price y is the price and x is the flat square feet. Okay, so based on that we can predict. This is the one example, but there are some example in real time where this x, that is the predicted variable, will not be single. For example, now it is a rainy season here, so north east monsoon season. So we want to know whether there will be a rain at Tamil Nadu or Karaikal, okay, or Puducherry, right? So in that case, the rain parameter, the rain depends on many parameters like wind speed, okay, and then the minimum temperature, maximum temperature. So y is the rainfall, y is equal to W0, W1x plus W2x2. Okay, because now you have minimum temperature, maximum temperature, wind speed, and so on. So you are going to predict with many factors. So that's why the linear regression is not able to apply. So you can apply this multiple linear regressions, so which involves more than one predictor variable. As I said, you'll be having x1 and x2, x3, x4. So the equation will become y0, y is equal to w0 plus w1x1 plus w2x2 plus w3x3 and so on. Okay, this is called as multiple linear regression. And then you have nonlinear regression. Some nonlinears can be modeled by polynomial functions. Okay, so you will be having equation like this. Polynomial regression y is equal to w0 plus w1x plus w2x square plus w3x cube. So in this case, we want to convert the nonlinear to linear. So you are assuming that x2 will be x square and x3 will be x3, x cube will be x3. So the equation will become, we are converting nonlinear to linear, and then you are trying to execute. This is the way to handle this nonlinear regressions. So these are the, I think some people are waiting in the lobby. We have to admit who has permission, please admit them. Madam, there are some people are, I think, in lobby, so kindly admit them. So let us.
They are in.
Okay. Let us take this example. Could you please do this exercise? The following table shows the midterm and final exam grades obtained for students in a data mining course. Okay. The following table shows the midterm and final exam grades obtained for the students in a data mining course. Predict final exam grade of the student who scored 75 in midterm exam. So this is the training data. This is the data. You have, now we have to build the model. Okay, we have to build the model. So y is equal to w0 plus w1 x. Now x is given. So this will be written y is equal to W0 plus W1 multiplied with 75. X is given. Now you have to compute this W0, W1. So what do? You compute X bar, you compute Y bar. Okay. So this it will not go. So you have to apply this equation for the data, whatever data I have shown, X minus X bar multiplied with Y minus Y bar. So what do? You form a table. Okay, the first column, let you keep X values. The second column, Y, you can have Y values. Third column, you can have, then you compute the mean of X, mean of Y. Then the third column, you can have X minus Xi minus X bar. Then fourth column, you can have Yi minus Y bar. Then fifth column, the multiplication of these two. Then next column, X minus X bar square. Okay. Then you sum this and you substitute here, you will get W. It will be easy. And then like that, you have to compute W0. Right. So I have given the data. Now it is your job to compute it. Okay. So I will leave it to you. So you try to find how this prediction model works. Okay. So this is nothing but the regression model. So you can try with the rapid miner also. I will open it. Sorry, I muted. Okay. So there are various measures to evaluate the performance of the model. Now, what happens in case of regression? you have to find the error. Okay, you have to find the error. What is error? The error is between the actual value and the predicted value. The actual value is represented as y, and predicted value is represented as y dash, yi dash. Okay, so what is the error? Yi, the actual value minus predicted value. Okay, if you take modulus of it, then it's called as absolute error. It's called as absolute error. So absolute error is one of the metric to evaluate the performance of the model. Then second one is squared error. If you square this absolute error, you will get square error. Yi, modulus of yi minus yi dash square. Then apart from that, you have generalization error. Okay. So there are two test errors. One is mean absolute error and mean squared error. Okay. What is mean absolute error? If you have the absolute error, if you take mean of it, then we will get mean absolute error. So we can see here summation I is equal to 1 to n modulus of yi minus yi dash divided by n. This is mean absolute error. And mean square error is nothing but if you square this, then you will get a mean square. If you take the mean of the squared error, then you will get it, right? So the summation of y is equal to 1 to n, yi minus y dash square divided by n. Okay. Then apart from that, you have relative absolute error. So this is a formula. Okay.
Sir, you are not audible. Hello? You are not audible, sir. Hello? Hello? Sir, you are not audible.
Hello. Hello.
Sir, you are not audible.
Hello.
Yeah.
I am audible
Hello?
now.
Yes, now you are audible.
Hello.
Yes.
Yes, there is some disconnection, madam. That's why I want to ensure
Yes.
it.
I thought you were speaking. Yeah.
Yeah,
Okay,
I
now
actually was speaking, but some
yeah.
yeah. Okay.
You can
So
continue.
yeah, I repeat it. Yes, there are many error measures are available to evaluate the performance of the model. The simple thing is we have to compute the loss function. That's called as a error, the actual value minus the predicted value. So yi is the actual value and y dash is the predicted value. So if you take the modulus of it, then it's called as absolute error. If you square it, it's called a square error. If you take mean of it, then it's called as mean absolute error. If you take mean of squared error, then it's called as mean squared error. Then if you take relative absolute error, RAE, then relative square error. So these are the various measures we have to evaluate the performance of the prediction model, that is particularly regression models. And we have root mean squared error, RMSE, that is a famous measure which is used to evaluate the performance of the prediction model. Okay, now I will move to the how to evaluate the performance of the model for classifier, which you discussed yesterday, the last session. Okay, quickly. Yeah. So when you look the classifier, okay, when you look the classifier, I have shown you the accuracy, right? I think this we discussed on the day. I think so, but anyway, I will repeat. So we have a confusion matrix. By using confusion matrix, only we can able to evaluate the performance of the classifier. Okay. So as I said, this row wise, the C1, C2, which indicates actual data. So this C1 and C2 indicates the actual, okay, and this is predicted. This one, okay, this is actual. So now this is called as the confusion matrix, right? So what it means, we have to understand this confusion matrix to evaluate the performance of the classifier. So this actually in the given data set, these tuples are belongs to class 1. But when you apply your prediction model on this data set, the model may be classified as sometimes correctly, sometimes wrongly. Okay. Suppose the tuples, actually these tuples are belongs to class 1. After applying your prediction, you can call it as positive, true positive. I am repeating it. The tuples actually, that instances actually belongs to class 1, and your model also predict, and it says that the tuple belongs to class 1. So it correctly classified, it correctly predicted. That's why it's called as true. Correctly predicted as positive. What about this C2? This is actually the tuples belongs to class 1, and now after applying your model says that these tuples belongs to negative class, okay, class 2. So what it means, it's wrongly classified. The tuples are wrongly classified, so it's called as false. Wrongly classified as negative. Actually, the tuples belongs to positive, but your model predicted that these tuples belongs to negative. So wrongly classified, that's why false, and classified as negative tuples, so negative. What about this entry? False positive. Actually, the tuples belongs to class 2, but your model predicted that it belongs to positive. So once again, wrongly classified, that's why false, wrongly classified as positive, false positive. What about this true negative? Actually, the tuples belongs to class 2. Your model also predicted that the tuples belongs to negative, so true negative. So this is called as a confusion matrix. Okay, and if you want to compute the accuracy, the accuracy is nothing but the diagonals you have to take. You have to take only the diagonals. True positive plus true negative divided by all. Okay, that's called as accuracy of the model, right? So there are many measures: accuracy, precision, recall, specificity, sensitivity, F1 score, ROC curve, and so on. But the accuracy is the important measure to evaluate the performance of the model. Okay. So the same thing is represented here. So C0 is a one class, C1 is one other class. Here also C0 and C1, and this is the actual. This is the actual class, and after applying the model, these are the predicted class. So N00 is nothing but the number of C0 cases classified correctly as C0. That's why it is 00. And see here 01. Actually, the tuples belongs to the number of C0 cases classified incorrectly as C1. This is entry. Okay, that's why it's called as this is true positive. This is false negative. Okay, what about this? N1, 0 is nothing but number of C1 cases classified incorrectly as C0. So it means false. Okay, and N11 is nothing but the number of C1 cases classified correctly. Okay, let us take some example and then how this confusion matrix is built. Okay, are you able to follow me, audience participants? Are you able to follow me? Could you please any one of the participant? Hello, hello. Yes, sir. Okay, thank you, thank you. Thanks for the response. Yeah.
Nobody is responding.
No. It's responding. They're responding in chat box. That's good. Okay, no problem.
Okay.
Okay. Thank you. So now what I'm talking about how to evaluate the performance of the model. See, when you do a project or when you do a research, once the model is built, we have to find how far the model is working fine. Okay. So in that case, we have to use this matrix. So already you talked about the metrics for prediction. Now I am talking about the metrics for classification. So now I have taken one example. Okay, see here. This is the one data set like how you have discussed no what is that, the COVID-19 data set. Like that, there is a one more data set where you had the income of the person, and then whether the person got married or unmarried, and then age. Okay, so age of the person, and then the income of the person, and then the income, age, and then we have one more, that is salary. Okay, so we have three informations, right? And then the last attribute is the cheat attribute, whether the person will be cheating or not. I don't know whether I have the data set with me or right now. So what we have to do now, we have to build a classifier. Okay, we have to build a classifier. We have to build a classifier, and then we have to check the accuracy of the model. Okay, I think whether I have this data. 1 minute. If I show the data, then it will be easy for you. Yes. Yeah, this is the data set. I hope you are able to see my data set. This is the data set. We have refund. Like no, you know that today our human life, right? How you are running our life? You are running our life with the help of EMI. You got my point. You have home loan, you have car loan, you have personal loan. Okay, you have all loans, right? So for each loan, you have to pay some EMI, correct? Now, this is a case study use case. Like people are applying for a credit card or a loan to the bank. Now, the bank wants to know whether to sanction a loan or credit card to the customer. So the bank will check the previous history of the customer. Okay, that is the data, training data. So the data has refund. What it means, it shows that yes means yes, the person already avoided some loan, he is refunding regularly. Okay, without any intervention, right? So that's called as yes. No means he is not a regular person. He will be paying some month he may not be paying. Okay, so irregular behavior. Okay, and another thing is all it depends. The refund depends on the marital status. If the person is single, he don't have any commitment, right? So you may be paying the refund regularly. Okay, but if he is married, a lot of commitment will be there, and he may not be able to pay the EMI regularly. Okay, and another important parameter is the income. If it is 80 gray, so he has huge amount, so he can refund the loans. But sometimes if it is less than 80K, he may not be able to refund the amount. Okay, so these are the three parameters, and the last one is the cheat. A cheat is the class table, you know that. No, 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 yes, yes, yes. So no means this guy will not cheat. Okay, so that the loan can be granted. And yes means yes, this guy may be cheating. So the loan cannot be granted to the particular person. Okay, the loan may not be granted to the particular person. All right. So this is the case study. Now, see, this is the data which is given. So here the no, 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 yes, right? It indicates that the actually the tuple belongs to first tuple belongs to no, second tuple belongs to no, third tuple belongs to no, like that. Okay, so this data I have taken here for understanding purpose. I have taken here. You can see now. My idea is to explain you how to build a confusion matrix. So this is a cheat. The first 5 rows I have taken. No, 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 yes. The first 4 rows are no, and the last one is yes. So after applying this data to my model predicted that the first tuple is no itself, and second tuple is moved from no to yes, and third tuple no, fourth tuple no, fifth tuple yes. Only there is a change in the second tuple. The second tuple is wrongly classified as yes. How to build a confusion matrix? So you can draw a table. You can draw a table. You can have class C1, that is cheat is equal to no. You can have anything, okay, and cheat is equal to yes. And here also cheat is equal to no. Or you can have it yes also. It's up to you. No issues. Okay. Now, actually, the tuple belongs to no, right? And your model also predicted as no. How many cases you have? One. Actually, the tuple belongs to no. Model also predicted as no. 1, 2, and 3.
Sir, you are not audible.
No sound, sir.
Hello? Sir, you are not audible. Hello? I'll just call him. Oh, okay, okay. No issue, no issue, sir. Yeah. He's, it's raining over there, so he just disconnected.
Hello.
Yeah, it's,
Am I are you able to hear me now?
yeah, you are audible now.
Thank you, bro. Thank you. Sharing once again my content. Hope you're able to see my screen once again. Yeah, so it's raining here, so I connected through mobile. Lot of disturbances there today. I'm sorry for
Oh,
that.
okay.
Okay. Right, right. So you are talking about how to build this confusion matrix. So as I said, so you can see the data, the first row and third and fourth row, where the classes are in same class. Like, actually it belongs to no class, and the model also predicted as no class. So I have entered 3 here. And what about this? What will be the value here? Actually, the tuple belongs to no, and your model says yes. How many instances you have like that? As for the second row. So only one. Okay. And what about this? Yes and no combination. You don't have any combination, right? Actually, the tuple belongs to yes, and your model predicted as no. You don't have any instances, right? So it will be 0. And then actually the tuple belongs to yes, your model predicted as yes. Yes, we have only one instances as per the fifth row. So 1. So this is the confusion matrix for your data set. So, but anyway, you'll be doing in programming. So, but you must know the theoretical knowledge, what is happening there actually. Okay, that is very, very important. How far you are good in programming is not only the matter, how far you are good in theoretical concept also very, very important. Okay, then if you want to compute the accuracy, as I said, the accuracy formula is this diagonals. True positive plus true negative divided by all. So in this case, so I want to compute the accuracy. Accuracy is equal to 3 plus 1 divided by all. 3 plus 1 plus 1 plus 0. So this is 5. 4 and 5, yes, this is 4 divided by 5. Okay. So it will be 0.8 will be the accuracy. Okay, and another measure is the classification error. Okay, classification error will be 1 minus accuracy, it will be 0.2. Okay, or if without accuracy you want to compute the classification error, then this diagonal you have to take false positive plus false negative divided by r. So 1 divided by 5. Okay, it will be 0.2. Got it? Okay, this is a way to build a confusion matrix. Okay, and then based on that we can evaluate the performance. So this is the one, and then If you want, I will show you one more PPT. One more example I will give you, then I will move to clustering. Okay. So, as I said, the accuracy is true positive plus true negative by all, and error rate is nothing but false negative, false positive plus false negative by all, and sensitivity is nothing but true positive divided by positive, specificity is true negative by negative. So, once you have the condition matrix, everything you can be able to calculate. Okay. So, this is one example you can compute. This is a bias computer example. So, what is accuracy? Accuracy will be this diagonals. You want to take this diagonals. 6954 plus, because this is the true positive, okay, as per this table, you can compare. And this is false negative, and this is the false positive, and this is the true positive, sorry, true negative. Okay, so you can compute the other measures also. This predictor error measures already we discussed. Okay, so with this, I will put a full stop for predictive analytics. Then now we'll move to clustering.
So can we break?
Yes, madam. Yes, we'll have a break.
If you need a break, okay. 10 minutes. It's 8:15 now. So by
Okay.
8:20 we can return back.
Yes, yes.
Okay.
Okay.
Okay, thanks. Hello. Am I audible?
Yes, sir.
Hello,
Yes, sir.
madam.
Yes, 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 yes. You are audible, sir.
Hello.
Yes, you are audible, sir.
Sorry.
Can you hear me?
Yeah, yes, yes. Yeah.
Okay, okay. Yeah.
Shall I continue?
Yes, you can continue.
So the next topic is clustering. So we have discussed about supervised learning. As I said, in machine learning, we have three paradigms: supervised learning, unsupervised learning, and reinforcement learning. You are not going to the third one, but we will talk about the unsupervised learning. The difference between supervised learning and unsupervised learning is, in supervised learning, we will be having class label. In unsupervised learning, we will not have the class label. Okay, the data will be analyzed with respect to the properties of the data. So what is clustering? What do you mean by cluster? Generally, people will say that cluster is nothing but a group of objects. That's called as a cluster, correct? The same way, here also, cluster is nothing but a collection of data objects. Okay, but how will make this group? How will make this collection? Okay, so we have to compare one data object with another data object, whether the objects are similar or dissimilar. We can say if the object is similar, okay, then the object will be placed in one cluster. If the objects are dissimilar, the objects will be placed in different cluster. Okay, so the main criteria in cluster analysis is nothing but finding the similarity. Okay, we have to compute the similarity between the data. All right, so that is very important. So how you are going to compute the similarity? Right, it varies from based on the type of data which you are going to cluster. Normally, most of the applications will be using numerical data, or which is also called as interval scaled variables. There are two. You can call it as interval scaled variables or numerical data. If it is a numerical data, always people will be using a metric called Euclidean distance. Okay, there are three types of distance: Euclidean distance, Minkowski distance, Manhattan distance. By using that, you can compute the distance between the objects. Okay, you got it? So clustering is a process which groups the object based on the similarity. The similarity will be computed based on the type of data. If it is numerical data, you will be using equivalent distance. If the data are text, then you will be using cosine similarity. If the data are binary, you will be using Jacob coefficient formula. Okay, right? You will see one by one. So it's used in various applications. It's used in pattern recognition. It's used in spatial data analysis, image processing, document classification, and document clustering, and so on. So you can say always a good clustering will produce high quality clusters with high intra-class similarity. Okay, it means that intra means within. Okay, and low inter-class similarity. So as I said, there are different type of data we have. You can see this slide. The data are basically classified into continuous and categorical. Okay, in continuous we have two type of, further you can classify continuous data into interval scaled variables and ratio scaled variables. And categorically, we have binary, nominal, and ordinal. I'm not going to touch all this data because it will take too much of time. It needs 2-3 hours. We'll see one example for continuous data, and then binary data. Then I will move to yeah, I will show for continuous data alone. Then I will move to the clustering algorithm, K-means clustering algorithm. Okay. So you can see here, normally what you used to do when you go for, if you use any numerical values, always we will try to standardize the data set. Okay. In the research paper, you might have noticed there is a word called data standardization. What it means, it's nothing but standardize your data set. It means that you are trying to scale all the attributes in the same scaling. Like for example, one attribute in the range of 10, another attribute value is in the range of 100, then you can convert both the attributes in the same scale. That's called as normalization. Another name for that is called as normalization. So there are three type of normalization we have: min-max normalization, z-score normalization, decimal based scaling. Among the three, z-score normalization is the mostly used one. So what it says, z-score, that is z is equal to which value you want to convert, that is x minus mean of that attribute divided by standard deviation of the attribute. That is the formula. Okay, by using that you can normalize the data set. Once it is normalized, then you can apply your distance. So as I said, there are three distance formula you can see here. One is the Minkowski distance. The formula is the distance between object I and j is equal to square root of q xi1 minus xj1 modulus of q plus modulus of xi2 minus xj2 modulus of q dot dot dot. Okay. So where I is nothing but xi1, xi2 and xip, and j is xj1, xj2, xjp. It's a two-dimensional data objects. Okay, and q is the positive integer. So if the q is 1, okay, then it's called as a Manhattan distance. D of I comma j is equal to modulus of xi1, xj1 plus modulus of xi2 minus xj2 plus dot 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 plus xip minus xjp. If the q is 2, then which is circled by red color, it's called as equivalent distance. This you can note down this formula because you will be using it. Okay, and even you will be using the Manhattan distance also. So the square root of xi minus xi1 minus xij modulo square plus xi2 minus xj2 modulo square plus dot 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 plus xip minus xjp modulo square. So these are the formulas. You have to just remember these formulas. Okay. So what is the importance here? These distance are used to find the similarity between the numerical data objects. When the two objects, there are two objects, then when you're trying to compare them, when you're trying to find whether these objects are similar or not, you have to compute the equivalent distance, the distance between the two objects. Okay, you can use, if it is clearly specified equivalent distance, you use it. If it is not specified, by default people will be using equivalent distance, because out of these three distance, equivalent distance is recommended by the expert. Or you can use Manhattan distance also. It's up to the application. Okay, right? If the q is 2, then it will become equivalent distance, right? Now, so if you have this, you can take this problem and you can compute on your own. Given two objects are represented by the tuples 22, 1, 42, 10 and 20, 0, 36 and 8. You try to compute the equivalent distance between these two objects. You compute the Manhattan distance between the two objects. You can compute the Minkowski distance between the two objects. Okay, this we can try on your own because you have the formula and you can do that. I will skip this binary object. I will move to this K-means clustering. Yeah, right. So now we are coming to the important topic. So if you look at the clustering, you have to understand two things. Simple. Clustering is nothing but grouping the object based on the similarity. Okay. So how we will compute the similarity? The computation of the similarity depends on type of the data. So So based on the type of the data, the computation cumularity will change. That's it. Okay, if it is numerical data, you are going to use any one of the distance which you discuss right now. One is Euclidean distance, Manhattan distance, Minkowski distance. You will be using any one of this when the data is made up of numerical. Okay, got it? If it is binary, you have separate similarity measure. If it is text, we have separate similarity measures. These things you can keep in mind. Now, so if you say clustering, the first one is what type of data are you going to cluster? Then second one is which clustering method are you going to apply? So there are many clustering methods available: partition based clustering, hierarchical clustering, density based clustering, grid based clustering. There are many things as I have specified here: partition based approach, hierarchical approach, and density based approach, then grid based approach, model based approach, frequent pattern based approach, user guided or constraint based. We are not going to discuss everything now. We will discuss only the first one, partition based approach, and if time permits, we will also discuss the hierarchical approach. Okay. So in the partition based approach, what they are trying to do, they are trying to construct various partitions and then evaluate each partition by some criteria. That is the concept in partition based approach. So the good example is the k-means. Some people, those who are knows data science and data mining or machine learning, they may know this name. It's a very popular algorithm. Okay, so we will discuss this k-means algorithm. So this is the algorithm. So here, what instead of explaining with the algorithm, I would like to explain with the example always, so that people can understand it. Okay, so but still you can go through that. It is a partition based approach. Each cluster is associated with the centroid, that is nothing but the central point of the cluster, and each point is assigned to the cluster with the closest centroid. It means that you will take some points and you have centroid, you will try to compute the distance between the centroid and each point, and if it is that point is very close to the centroid, then the point will be assigned to the cluster. Okay. And another important thing is here how many clusters you want, that is k. K is nothing but the number of clusters. It will be specified by the user. We wanted to send 2 clusters. K is 3 clusters. That is the drawback also, because you have to supply the k. Okay. So select k point as the initial centroids. Repeat, form k clusters by assigning all points to the closest centroid. Recompute the centroid of each clusters until the centroids does not change. Okay, let us take the example and discuss, so that always by explaining with the example is good. Okay, so cluster the following 8 points representing the location into 3 clusters. So what it means? What is k now? What is k now? What is k? Yesterday we had a lot of, last session we had a lot of interaction. Today, oh, k is 3. Thank you, Power. Some name I am not able to see completely. Some Power has replied. K is 3. Okay. So there are 8 points we have. Okay. 2, 10, 2, 5, 8, 4, 5, 8, 7, 5, 6, 4, 1, 2, and 4, 9. Okay. Now, what is the logic behind this? First, we have to select the cluster. So here you can say how many clusters you want? You want 3 clusters. So cluster 1. This is C1. Okay. Then cluster C2. C cluster. Then cluster C3. So 3 clusters you have. Now, each clusters will have centroid, that is central point. So that will be nothing but initially you will select randomly from the given points. Any point can be the centroid of the clusters. So in this case, I have assigned for A1 it is 2, 10. Okay, 2, 10 is the centroid of the cluster 1, then 5, 8 for the centroid of the cluster 2, and 1, 2. Why these points only, sir? Why not others? Yes, you can go. You can go with other points also. No constraints. Simple Find the k. If the k is 3, you will have 3 clusters, and each cluster there should be centroid. It should be assigned from the given points randomly. Any point can be the centroid of the cluster, no issues. Got it? Then in this case, they are given Manhattan distance is the formula. Okay, so if there are 2 points, A is equal to x1, y1, and B is equal to x2, y2, then you will find the distance between A, B is nothing but modulus of x2 minus x1 plus y2 minus y1. Okay. Now, so what you have to do? You have formed the 3 cluster, cluster 1, cluster 2, cluster 3. Now you have to assign the points to this cluster. So what you will do? You will compute the distance between this centroid to the all the points, and like this you will compute the distance between this centroid to the all the points, and like this you will compute the distance between C3 centroid of C3 with the all the points. Okay. Okay. So this is the graphical representation of the all the 8 points. All the 8 points are represented. Okay, see this A7 is 1, 2, right? And A2 is this 2 point. This is 2, 5. Okay, right? Now this is the randomly we have chosen. This is centroid. So as I said, there are 3 clusters. Each cluster, some points are assigned as the centroid of the clusters. Okay. Now what you can do, you can have a table like this. You can have a table like this. So here, this is a cluster 1, C1, and this is cluster 2, C2, and C3. I will call it as CC1, CC1, CC2, CC3. That is centroid of cluster 1, centroid of cluster 2, centroid of cluster 3. The centroid of cluster 1 is as per this. The centroid of cluster is 2, 10. Centroid of cluster 2 is 5, 8. I have chosen randomly, right, from the given points. Centroid of cluster 3 is 1, 2. So 2, 10, 5, 8, 1, 2. As I said, we have to compute the distance between the centroid of the each cluster with all the given points. So you have 8 points, A1 to A8, which are given here. Now we have to compute the distance between this, and distance between this, and distance between this. So if we do so, here the values are given. You have to do on your own. For example, 2 minus 10, 2 minus 2. What is the formula? How we will compute the distance? What is the formula here we have to use? This is a formula. See here, this is a point, and this is the centroid of the cluster 1 is given. Okay, 2, 10. So what is the formula? The distance between A, B is x2 minus x1 plus y2 minus y1. What is x2? 2. What is x1? 2 minus 2 will get 0. Okay, and then 10 minus 10 will get 0. So it is 0. Okay, that's why this value is 0. That is the distance between this point and this centroid of the cluster C1. Centroid of the cluster C1. The next, you have to compute the distance between this point and centroid of cluster C2, which is nothing but 5, 8. So you can see the points A, but now the centroid of the cluster is changes. So x2 minus x1, 5 minus 2, 5 minus 2, 3, 8 minus 10. Okay, so more or less, so it will be plus 2. So it is 5. So it is centered as 5. Then compute with the third point, that is 2, 10 with the third cluster, centroid. Okay, so the third cluster centroid is 1, 2. So 1 minus 2, it will be 1. 2 minus 10, it will be 8. So 1 plus 8, 9. So 9. Now you can see which value is less. So this is the distance between A1, distance between A1 and CC1, which is 0, correct? And then distance between A1 and CC2 is 5. The distance between A1 and CC3 is 9. Which one is minimum? 0 is minimum. So you are concluding that this point goes to cluster 0, cluster 1, this one, cluster 1. Like that, you have computed for all the points. Okay. Now let us take the second one, 2, 5. So compute the distance between A2 and CC1. A2 is 2, 5 and CC1 is 2, 10. So 2 minus 2, 0, 10 minus 5, 5. So 5. And this one, 5 minus 2, 3, 8 minus 5, 3. So 3 plus 3, 6. Then this one, 1 minus 2, 1, 2 minus 5, 3, 4. So which one is the minimum in this? 4 is the minimum. So it means this A2 point goes to this cluster, cluster 3. Okay. Then take the A3. Take A3. What is the point A3? 8, 4. Okay, 8, 4. So 8, 4, the distance between 8, 4 and CC1, that is 2, 10. So 2 minus 8, 6. 10 minus 4, 6, 12. Then 7, 9. Like that, if you iterate the process, you will get these values. So as per this A3, you are getting distance towards 7, 9. Which one is minimum? 7 is minimum. 7 is the distance between centroid of cluster 2 and A3 point. So since it is minimum, A3 is assigned to clusters 2. What about A4? A4 point is 5, 8, and if you compute the distance between all the centroid of the various cluster, for the first cluster it gives 5, for second cluster it gives 0, third cluster it gives 10. So 0 is the minimum, so it goes to second cluster. Then 7, 5, if you compute the distance between 7, 5 and all the points, for the first point it gives 10 is the distance, and the second centroid it gives 5. Third one it gives 9. So which one is minimum? Centroid of cluster 2 is minimum. So it is assigned to cluster 2. Like that, A6, 10, 5, 7. Among the 10, 5, 7, 5 is the minimum. So it goes to once again cluster 2. Then 7th point, 1, 2. The distance between first cluster and this point is 9. And the distance between cluster 2 and this point is 10. And the distance between the third cluster 3 and this point is 0. So 0 is minimum. So it goes to cluster 3. Last one, A8. It is 2, and for cluster 3 distance, so which one is minimum? 2. So this point also goes to 2. So based on this result, cluster 1 has only 1 point, 2, 10. Am I right? Cluster 2 has how many points? 8, 4, 5, 8, 7, 5, 6, 4, 4, 9. All these points comes to cluster 2. Then cluster 3 how many? 2, 5 and 1, 2. So these are the 3 clusters now. These are the 3 clusters. Okay. Now this is not stopped. What you supposed to do? The next one is we have to see when we can stop this. If there is no change in this centroid of this cluster, then we can change. So you have to compute the centroid. What will be the centroid? So if you compute the centroid in the cluster 1, we have only 1 point. So no need to calculate, because this will remain as a centroid of the cluster. Only 1 point we have. But cluster 2 we had 5 points. So we have to take the average. So 8 plus 5 plus 7 plus 6 plus 4 divided by 5. Then 4 plus 8 plus 5 plus 4 plus 9 divided by 5. So we will get new centroid of this cluster 2. Okay, I have given here. So cluster 1 only 1 point. So it will be same. The centroid of the cluster is same. But for cluster 2, we have to take average. So the new centroid of cluster 2 is 6, 6. And cluster 3 also we added 2 points. So if you take the average of it, that's why it's called as K means. You got it? What is K? K is the number of cluster. Mean is nothing but you are using this mean concepts to find the centroid of the cluster. Okay. So you are trying to compute the mean to, sorry, you are trying to compute the mean of the points belongs to that cluster to get the new centroid. So cluster 1 there is no change, but cluster 2 now the centroid got changed 6, 6, and cluster 3 1.5, 3.5. So it got changed. So you cannot stop the iteration. So you have to repeat it. So now this is the cluster 1 now. This is a C1 and this is C2 with the new centroid. Okay. So cluster 1 has A1, cluster 2 has these points, cluster 3 has these points. And if you compute the centroid, now it will become like this. Now what are you supposed to do? You have to compute the distance between this C1 with all the points. And once again, the distance between the new centroid of cluster 2 with all the points. Then once again, compute the distance between the new centroid of cluster 3 with all the points. So if we do so, once again, we'll get the table. Okay, 2, 10, 6, 6, and 1.5, 3.5. So with the first point, if you take any of it will goes to the first cluster. The second point, if you take, it goes to C, we are getting 5, 5, 2. So it means it will go to cluster 3. Okay, like that you have to do. You have to do the calculations. If you do so, what happens? You will get, now there is a movement. Cluster C1 is getting one more point, A1 and A8. Okay, I am not, the mathematical representation is stopped actually. You can do it. Okay, I have stopped up to this. So you try to compute this iteration and finally you will get cluster here. So accordingly, if you do this iteration 2, what happens here? Cluster C1 has the 2 points. And earlier we had 5 points in cluster 2, right? Now we will get only 4 points. 1 point is moved to cluster 1. And cluster 3 has still that same 2 points. Okay, then if you, once again, we have to compute the new centroid of this cluster, because A1, A8, earlier you had only A1, now you have A1 and A8. So if you compute the new centroid of the cluster, and then like this here also you have to compute the new centroid of the clusters. So that's why here I have written. Okay, so new centroid will be computed, and then once again we have to compute the distance between the new centroid of this cluster with all the points. So if we do so, the next iteration what happens? We are getting some more point. Okay, C1 has A1, A8, A4, C2 has A5, A3, A6, C3 has A7, A2. If you do further iteration, there is no change. The centroid of the cluster doesn't change, or you can say the members of the cluster doesn't change, so you can stop the iteration. So according to this, we have 3 cluster. Finally, the cluster C1 has A1, A8, A4, and cluster C2 has A5, A6, A3, cluster C3 has A2 and A7. Any doubt in this? I have shown the iteration 3 and 4 in figure. I have not shown in mathematical. Okay, I have not solved it. Actually, I have solved it. Based on this diagram is written that you have to do it. Like I have done up to this. You have to do this. So if you do so, you will get like this. Any doubt on this K-means clustering algorithm? It's a famous and mostly used clustering algorithm. Only drawback is you have to specify what is K. Okay, so in this case, K is 3, so you have taken 3 clusters. You can try, you can solve this same problem when K is 2 clusters. You can try on your own. Okay. Any doubt? Any queries as of now? K means clustering. If you don't have a doubt, then I will move to hierarchical clustering. Yeah. So the next type of clustering is hierarchical clustering. In hierarchical clustering, we have two subcategories. Okay, from the name itself, we can say hierarchical. It means it is not in one place. It is placed in different hierarchy, different level of hierarchy. The data is placed in different level of hierarchy, low level, middle level, high level. That's called as hierarchy, right? It's called as concept hierarchy. We used to call it as a concept hierarchy. So here the data will be represented in different level. It will be in lower level, it will be in middle level, it will be in higher level. So there are two type of hierarchical clustering methods. One is agglomerative hierarchical clustering, and second one is a divisive hierarchical clustering. Agglomerative is also called as bottom up. Okay, what it means, you will be having the small clusters, and then you will just take some commonality between the clusters, and then you try to merge the two clusters. Then like that you will do it. We'll keep on continue the iteration so that at the end you will get only one cluster. That's called as agglomerative, or which is also called as bottom up. Okay, we'll take small clusters, and based on the commonality. For example, I have 4 clusters: cluster 1, C2, C1, C2, C3, C4. Then let us assume that C1 and C2 has some commonality, so C1, C2 will be clubbed, and then C3, C4 has some commonality, so it is clubbed. Then these two will be clubbed. That's called as agglomerative. At the end, you will get only one cluster. Divisive is reverse, and it is also called as partitional approach, and it is also called as top-down approach. Okay, what it means is there will be some common clusters, and based on some difference, we will be splitting it into subclusters. Okay, that's called as divisive clustering. Okay, separate all examples immediately into clusters. So let us take. So this is the algorithm behind this hierarchical clustering algorithm. Start with all instances in their own cluster until there is only one cluster. Among the current clusters, determine the two clusters Ci, Cj that are most similar. Replace and Ci, Ga with the single clusters Ci union Cj. Okay. And so here you like to take the data are text data. So as I said, the clustering is nothing but grouping the object based on the similarity. So how you will compute the similarity? If it is a text, you will be using cosine similarity. Using cosine similarity, you will try to convert the documents into vectors. First you will convert the documents into vectors. There are many methods are there. Then based on these vectors, we will try to compute the cosine similarity. Okay. So how to compute the similarity of two clusters, each possibly containing multiple instances? In such a case, we have to follow 3 categories. We have single link. When you can similarity of two most similar members will do. If you use single link, for example, C1, C2 is combined, and C3, C4 is combined. Now, whether you want to compute these two or not, we have to find, we have to use any one of this. If the similarity of two most similar members, then we can go for single link. If it is single link, we will go for two most similar members. Complete link means two least similar members. Okay, group average is combining these two, average similarity between the members. Okay, I will explain this example so that you will get clear. So this is a single linkage. The similarity between Ci, Cj is equal to the maximum. Okay, and in case of a complete link, you will take minimum. That's why here it is written a single link. You will take two most similar numbers because you are considering maximum, and in complete link you are computing minimum. So we will try to see two least similar numbers. Okay, this is just you will skip this. So let us take one divisive clustering approach, how it works. We'll take one example. So this is you can see there is a one common cluster, and based on some criteria which is further divided into A, and BCDF is another cluster. Further BCDF is divided into BC and DF. Further DF is divided into DE and DF, and DE further split into D. So at the end, you will get single cluster. This is called as divisive clustering. Okay, so it's a reverse. Agglomerate means bottom to top, divisive means top to bottom. Let us take this example. See what happens now as a faculty, we used to give assignments to the students, right? They will be submitting some documents. Let us stop the hard copy. You try to collect it as a soft copy, okay, and then you apply this clustering. What is clustering? It finds the similarity, whether assignment 1 is similar to assignment 2. If it is similar, it will be placed in one cluster, then for both of them will award 0 mark because it's copied. Okay, so we'll try to compute the similarity value. If the similarity is 0, okay, then if the similarity is 0, then it's good. If the similarity, for example, we have document 1 and document 2. Okay, and if it is 0 means it means, for example, if that both the documents are similar, then the distance will be very less, right? So then we can award the mark accordingly, right? So this is mainly used for document clustering. Now let us assume there are 4 documents. Document 1, go monster go. For understanding purpose, I given like this. Document 2, go correcting. Document 3, correcting monster. Document 4, monster monster. Now we have to cluster this document by using hierarchical clustering. First step is we have to find the vectors. Okay, so we have to draw the matrix. Okay, we'll draw the matrix. In the row, we will be having the document, and column will be having the word which occurs in the document. Okay, so actually there are a lot of text pre-processing are there. I am not going to talk about that. Like you have to do tokenization and streaming, okay, and stop word removal and so on. But I'm not going to touch upon that. That later on we can come to know. Okay, so I'm just converting into simple vector here. So go, the first document, it occurs 2 times. That's why 2. Okay, and monster, whether it occurs in the document, yes, so it is 1. Whether correcting, you have taken all the keywords, go monster correcting, and go occurs only 2 times in the document 1. Monster it's occurring only 1 time in document 1. Correcting is not appearing in the document 1, 0. Then document 2, okay. So go correcting, go occurs only once and correcting occurs 1, but monster is 0. That document 3, correcting occurs 1. Sorry. So correcting occurs only 1 here. So 1, monster occurs 1, and this go is not there in the D3. So that's why it's 0. Okay. Then D4 monster occurs 2 times. Other words are not appearing in this document, so it's 0 0. So this is nothing but converting your text into vectors. First step. After that, you find the length of the each document. The length of the each document is nothing but the square root. Okay, we have to find the modulus of D1. Okay, we have to find the square root of the vectors of the each document. So the document 1, what is the vector? 2 1 0, right? So just we are taking the document is nothing but 2 square plus 1 square plus 0 square, then square root 5. So square root 5. Then like that, say document 2, 1 square plus 1 square plus 0 square, so square root. So square root of 2. I hope it is clear. Then document 3, we look at the document 3, 0 1 1 1. So if you take square, 0 square, 1 square and 1 square, it will be square root 2. And document 4, similar way, 0 square, 2 square plus 0 square. Square root of 4, it is 2. So this is nothing but finding length of the each document. So first step is we have converted the text into vector, and second step is we have computed the length of the each document. The third step is you have to find the similarity of each document, okay, using similarity function. So that's why I said no cosine similarity. This is the cosine similarity. Similarity between document DI and DJ is nothing but summation of K, WIK, WJK divided by modulus of DI and modulus of DJ. Excuse me. Okay. So you are trying to apply this cosine similarity. Similarity of DI comma DJ is equal to summation of K, WIK, WJK divided by modulus of DA and DJ. Now we have this value, right? This weight, this vector values. So here K is you can see here. Okay, so K is 1 comma 2. So first we'll take the first value. There are two documents here, right? So WI1, WJ1 first. So WI1 here it is 2. Okay, 2. This document, this is WJ1. So you have to multiply this 2 into 1, and then 1 into 0, then 0 into 1. Okay, so 2 into 1, first one is done. Okay, then second, first word, okay, and then the second word, and then third word. There are 3 words between the document D1 and D2. And what is the denomination? Modulus of DI is nothing but the length of the document which you computed. So DI is 1, so it is square root of 5. Then DJ, that is 2, so square root of 2. Okay, so 2 by square root of 10. This value will get it. So the similarity between document and D1 and D2 is 0.6324. Now you want to compute the similarity between D1 and D3. So D1, D3 already we have vectors. D1, this is D1, and D3 we have to. So now we have to compute this 2 into 0, 1 into 1, okay, and 0 into 1. Anyway, this will become 0, this will become 0, this will become only 1. So 0, 1, 0 here. This will become 0 numerator, and your denominator is going to be document of the length of the document D1 is square root of 5, D3 is also square root 2. So it will be 1 by square root of 10. So this will give you the value 0.3162. Then D1 and D4, similar way we have to do it. So we'll get 0.4472. Similarly, if you do for D2, D3, you will get 0.5. D2, D4 will get 0. And D3, D4 will get 0.7071. Okay. Now you try to compute the, construct the similarity matrix between document 1. So document 1, 2, 3, 4 and document 1, 2, 3, 4. So the distance between D2 and D1, which we computed recently, D1 and D2 is 0.632. And distance between D3 and D1 is 0.312. The distance between D4 and D1 is 0.442. Like the distance between D2 D2 is same, it's identical matrix, and identical, and D3 and D2 is 0.5, and D4 and D2 is 0. Okay, and D4 and D3 is 0.7071. Okay, all things are there. So just I have constructed the similarity matrix. I repeat what I did. First step is to find the vectors. You converted the text document into vectors. Then you have found the length of the document. Then you are trying to find the similarity between the document using cosine similarity. Okay. Then based on this, you have to construct a similarity matrix. Okay. As of now, it is clear. Now, what do you do?
Yes.
Okay, thank you. Now you can compute the minimum spanning tree. Okay, MST from the above similarity matrix by using either Kruskal or Prim's algorithm. Here you will use Kruskal algorithm for the sake of simplicity. So what it says, you try to arrange the edge. Okay, so if the similarities are highest to lowest. So in this case, the D3, D4, the document between D3 and D4 is the highest similarity. The next one is D1, D2. The next one is D2, D3. Next one is D1, D4, D1, D3, and D2, D0 finally. Okay, this is the matrix values. Okay, similarity values, sorry. Okay. Now we can use greedy approach. So first you connect D3, D4, okay, with the similarity 0.7071. Okay. So it means what is this algorithm says? The final MST can be constructed by connecting all the edges between points starting from maximum until all points will be participated and no closed loop or circuit is formed. So first what happens here, I repeat here, you have computed the similarity values, you have constructed the similarity matrix, and then you have to order the document similarity based on the highest similarity values. So D3, D4 has the highest similarity, D1, D2 has the next similarity, the next lowest, it goes like this. Okay. Now what it says, you try to connect the object, the documents which has the highest similarity value. So D3, D4 has highest similarity. So we will provide the edge between this D3, D4. Next highest similarity is D1 and D2. You just look here, D1, D2. So we will get D1, D2. Okay. The next one is between D3 and D2. D1 and D3. Okay. Sorry, D2 and D3. You can see here D2, D3 is the next one, 0.5. So that's why it is connected. Like that it goes on. So now we have to, so far what you did, you have computed the similarity, and based on similarity, you have connected the edges. Now you can, any of the linkage method, you can use any of the linkage method to form the clusters in top-down fashion. Okay. So here in this case, we are going for complete linkage. We have seen single linkage, the maximum, and then complete linkage is the minimum, goes like this, right? So I would like to use the complete linkage method to break the edges of the final MST according to minimum similarity. The complete linkage is minimum. All right. So what happens here? You will try to break the minimum similarity. So this is the graph which you obtained, right? So this is the final graph which you obtained. Now you have to break this. So which one is as minimum similarity? D3, D2 as minimum similarity. First it will be break. Then D1, D2 will be break. Then D3, D4. So like that it goes on. So finally we'll have the one D1 and D2, D3, D4 is the one cluster, and C3 as D2. Further it will be decomposed, and you will get C2 is D3 and C3 is D4 and C4 is D2. Like that it goes on. Okay. Right. So this is the divisive clustering. This is the up to this top down. Now you are applying the divisive. Okay. So if you draw the dendrogram, you can see D1, D2 formed once and D3, D4 formed, and then these two match. This is the dendrogram in the hierarchy cluster. So any doubt? So what you discussed, you have discussed two important clustering algorithm. One is the K-means clustering algorithm, and second one is the hierarchical clustering, where what you try to do, you have taken some text data, and then you have tried to apply this hierarchical clustering. Okay, where we have used cosine similarity to find the similarity, and then we have used agglomerative as well as the divisive. Okay. Yeah. Any doubt? I've done. If you have any queries, you can ask me. So, like how I have shown the tool yesterday, the same way we have to use the tool. Wait. You have to show the similar way to cluster the object. Simply, if you want, I will show one example on it. For clustering, read Excel. I'm trying to read my data. For understanding purpose, we having some data here. One minute. I would like to read some data. I think I have some data with yeah, I will take this age data. Okay, I will read. You can see just I had some files like there are 50 data are there. So I would like to cluster it. So I like to use k-means clustering. Okay. So k-means clustering. I supplied my data to the clustering part, and it is a k-means, right? So you can keep your cursor here, and you can see k is 5. So I don't want 5, I want only 2 clusters, right? So I have specified k is 2, and then run. I want to see the clusters, so run the process. Now you can see the cluster 0 has 35 items, cluster 1 has. If you want to folder view, you can see cluster 0. So these are the objects under the cluster 0, and these are the objects in cluster 1. Okay, right. This is the diagrammatical pictures. You can see this is cluster 0, and these are the members in cluster 1. Okay.
It's easy over here. Easy using the tool.
I am using the tool, yes.
Yeah, it is very easy when you use the tool rather than writing the code.
Yes, yes. But you have to, yeah, understand
Learn the
this
tool.
sometimes. Yes, yes. You have to understand the theoretical concept as well as, and then you can implement in the tool. That's why it's a plug and play, madam. So it's easy. But while writing your own algorithm, you have to integrate with the Python, and you can write your own code. That you can do. Okay. Any queries?
Sir, am I audible, sir? Hello.
Yes, yeah, you are audible, sir. Your good name?
My name is Prashant, sir.
Yeah.
My question is, sir, if as the number of clusters should be given by the user, right? So how to decide the value of k so that we can minimize the outliers or we can minimize the error.
Correct. That is a drawback of k-means because the result depends on k. So we have to compute the k, sir. There are many methods for that. There are many people have proposed. Based on type of data, also people have fixed the k, sir, dynamically. Instead of getting
Oh,
from the user, people have depends upon type of data and nature of the data. The k is computed. People have written many concepts for that. Yes.
okay. So technique also varies with the what type of data we are handling.
Not type
Is
of
that
data, you can say it's nature of the data. Based on the data which you are using, based on that, the k can be fixed.
okay? Okay, okay. Actually, it means since we are taking, if say we are taking say only 10 samples or 10 data points, then two clusters are sufficient. Means it's upon user how how you decide the count of
Yes,
that.
that's what I'm
But as the
saying. But
as
that's
the
what
yeah.
there are many methods to find the k itself. You can use that.
Okay, 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 fine, sir. Thank you.
because in k-means that is the drawback. Like not only k-means, even in the classification we have k and n. Like we discussed yesterday, Bayesian. There is one more algorithm, k nearest neighbor. So where how many neighbors you are going to consider is important. So k. So finding k is a problem. Okay, so you can think of how to solve this. Okay, people have proposed. There are many people have proposed, and there are many papers which discuss about this. You can just have a look on that. Yes.
Okay, okay, sir. Because it's as it is unsupervised learning, so it's kind of contrary that user has to give the most important, most important that key.
Correct. 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 Correct.
Yes, sir. Thank you so much.
Any other doubt? And one more thing, yeah, one more thing I want to show you. You can see here. See, this tool is very, very useful. You can do deep learning also. Okay, so just note down here. You can click this in the menu. You can click this extension. Okay, and then marketplace. You have to click this. And now we will get a dialog box where you can see the top downloads. It means that when you install this tool, no, basically it will have some default operators only. But if you want to go for advanced operator, then we have to add that. So I will show you one. For the for text processing itself, we have one add-on. For web mining, we have add-on. I told you, no, we can integrate Python. So Python scripting to be installed. It is already installed. So what you supposed to do? Select this, then I will show you. See, like this it will come. If you want to add this add-on web mining, it will come. Select for, see, in the right hand side you can see select for installation. Select it and then click install on packages. It will be installed. So like this Python to be installed here. Okay. So once but how to do with the Python? First step is we have to install Python in our laptop. Python to be installed, RapidMiner to be installed, and while installing Python, you try to note down its exe location. You keep with you, okay, and then install the RapidMiner. In the RapidMiner, you add this Python scripting. If it is done, then what you have to do? Go to connection, not connection, settings, then preferences. References. Now you can see if the Python scripting add, you get this Python scripting here, and here you have to see the binary path. We have to specify the location of the exe file, and then press test. So you will come to know whether the Python is installed properly or not. Okay, just a minute. Let it. So yeah, I will try to close this because it is installed in my case. We will see whether all the machine learning libraries are installed, whether pandas or numpy, scikit-learn, everything is installed. Okay. If you are using Anaconda, no issues. It is easy. Otherwise, if you are using only Jupyter and we have only basic Python, then you have to install all these scikit-learn libraries and everything, and then we have to integrate this tool. Why I am telling this? No, for some portion this tool is very important, but when you want to write your own code, then in that case we have to depend on Python. Okay, so some portions like pre-processing and other things you can read the data and you do it, and then you can write your own model here. Okay. So it's taking time. So I can yeah, see here. This will come like this. The Python is set up correctly. Okay, detected Python 3.92. You can see all the libraries. So it means is everything is fine. So I will show you one. Okay. Open the process. Um, 1 minute. Okay. Otherwise, I will tell you quickly. You can note down it. So, what we have to do? Yeah. How to use it? There is a execute Python. Execute Python. Okay. This is the operator to write you see, I have added this operator, right hand side you can see the parameters for this operator script. You click this, you will get this one. Okay. So this is some built-in Python is written here, hello world, right? It is hello world program. So you can write your script, your Python script here. This is a one way. Otherwise, what we can do, you can write your Python script in Jupyter and you can just call this file here. Okay, and you can supply the data, whatever the data you want to have it here, you can add the data and then you execute the Python. So that data will be read and then the Python's code will be applied on the data, you will get the model. Right. So like this, we can do many things. Only thing is, it is up to us how much you are going to learn. How we learn if you use the tool frequently, and we have to explore more. We have to explore on our own. Then that is the only possible way to read this kind of tool, understand this kind of tool, and use the tool. That is very, very important. So with this, I will stop my presentation. And so if you have any queries, you are always welcome. And for further contact, you can note down my mail ID, vengishakti77@gmail.com. This is my personal mail ID, and otherwise you can have venkadeshan.msundaram@natpy.ac.in. Okay, so these are the two mail IDs and this is my contact number. Okay, so if you need any help or for any further talk or any project you wish to do under the data science or machine learning, please let us know. Okay. I may not
So
be.
please, can you put it into chat box?
Yes, I will do that.
Copy it into the chat box if somebody needs.
Yes, yes, I will do that.
Yeah.
Yeah. Yes, done. So,
Thank you.
yeah, we can always welcome, right?
Yeah.
So I thank the opportunity given by the institute and by the organizers. Thanks for this great opportunity. Hope we will have a collaboration in the future also. Thank you.
Yes, sir, surely, definitely. We look upon to having another collaboration with you. Any
Yeah.
type, I mean.
Yes, yes.
Yes. So, any more questions or otherwise we'll take a quick photo. So kindly on your video so that I can take a photo. And the feedback link and attendance is shared in the chat box. So you can just share it. So can you stop sharing your screen, please?
Yes, yes, yes.
Yeah. Otherwise, share your PPT. Yeah. Thank you. Thank you.
Thank you, madam.
So attendance is shared in the chat box. You please mark the attendance for today.
Thank you, madam. Thank you, sir.
Thank you.
Thank you. Thank you.
Thank you, sir.
Thank you, sir. Thank you, madam.
Kindly forward the feedback and so that I will see. I will
Yes, sir,
send you
definitely.
the, I will
I
send
request the
PDF.
participants to, yeah, sorry, what are you saying?
I will send you that PDF of both the content and I will send it to your mail ID. madam.
Yes, sir. Tomorrow they have to appear for the test. So please send the PDF.
I will try to do it today night itself. Don't worry.
Yeah.
I will
Okay,
send it.
okay. Yeah.
Okay, thank you. Thank you.
And Monday they all will be coming to our campus.
Oh,
So yes. So Monday, so for all the participants, so be there for at 10 a.m. in the morning. So we'll have an inaugural and then it will be followed by a session on our program.
oh, that's nice. Okay.
1 week they are coming.
Okay. Yeah. Thank you, madam. Good night.
Okay, thank you.
Yes, sir. Thank you.